This Module 4B video begins in Part 1 by describing the regioselectivity of Diels Alder cycloadditions favoring one constitutional isomer. As described in the worksheet, we can calculate electrostatic charges on atoms using Spartan, and in general, electronegative carbons will have negative charge, electropositive hydrogens will have partial positive charge. But in the case of substituted hydrocarbons, this can change the level of partial positive charges. For example, for the diene with two alkyl substituents, the carbon that is most substituted is actually partially positive, with the partial negative charges distributed elsewhere in the structure. There is also a strong effect with a methoxy group, where the electron withdrawing effect of an electronegative oxygen is counteracted quite strongly by electron donation from non-bonded electron pairs, so that not only is the carbon attached to oxygen electropositive, but the adjacent carbon of the alkene is strongly electronegative. The effect follows the same trend with an alkyl substituent, but it is less dramatic. As we scroll down the screen, the trends follow trends that we've already seen with other patterns of reactions with simple alkenes, and even going back to some of the substitution chemistry covered at the end of Chemistry 202Z. For example, for the dimethyl substituted butadiene, there is a minor resonance form with positive charge on the tertiary carbocation, and then the negative charge is on the secondary position, and that can be in resonance with negative charge on the primary position. A similar effect is present with the methoxy group. In this case, resonance delocalization involving a non-bonded electron pair on oxygen leads to a minor resonance form with negative charge on the adjacent carbon. I'll show some Spartan videos for a couple of these compounds that exemplify the effect, especially on the highest occupied molecular orbital. This is 1,3-butadiene. Note that the pi bonds are not perfectly planar to avoid non-bonded interactions between the hydrogens at the termini. This is Cy1. All of the p contributors are in phase. And then Cy2 is the HOMO at minus 6.2 electron volts. Cy3 is the LUMO. And then Cy4, which is difficult to visualize, but is not that important for reactivity. Now I'll turn to 2-methoxy 1,3-butadiene. This is the structure of 2-methoxy 1,3-butadiene. Again, not perfectly planar. This is Cy1, which is heavily weighted toward the alkene component away from the methoxy group. The HOMO is heavily weighted toward the carbon that is adjacent to the methoxy group and is also at a higher energy level. And then we have the LUMO as before, and Cy4. Turning to the second page of the worksheet, we can now use this analysis to predict which constitutional isomer will be favored. For the diene, if the most substituted carbon is partial positive, then we can alternate partial negative, partial positive, partial negative, so that the unsubstituted carbon is more nucleophilic than the more substituted carbon. We know from the conjugate addition section of the previous module that the LUMO of an alkene with an electron withdrawing group is electrophilic at the terminal alkene away from the carbonyl. Another way to do this analysis is to assign polarities on the carbonyl corresponding to electronegativities. And that also works to show that the terminal alkene is electrophilic. Although this reaction occurs in one step, there is a preference for an orientation in which partial negative reacts with partial positive. And that corresponds to this product. In class, we'll discuss the differences between these two constitutional isomers, and I'll ask if there's any reason why this might be a surprising outcome. Scrolling to the bottom of the page, I'll ask you to work Part 2 and Part 3 on your own, and then we'll discuss those in the class meeting. Turning to the next page of the worksheet, in Part 4, we compare the results upon simply heating the two reactants versus reaction with the Lewis acid, which actually proceeds at room temperature and even better at slightly below room temperature. Please come prepared to discuss a claim where you will circle the appropriate words in this sentence. The evidence is data that is in the textbook. And then we'll discuss the reasoning, linking claim with evidence. This concludes the first video in Module 4B on regioselective Diels Alder cycloadditions.